I would love it if you guys want to just, either say something in the chat if you can't talk out loud or if you don't have a microphone. But if you do, I would love to hear your voice and hear you talk too. That would be great. So I don't feel like I'm talking to myself, which I feel like a lot of the time, so I don't want to feel that way. So let's look at the first one with simplifying these with the exponent. So can somebody just give me an idea of where you think you might start on this? There's a few different places that would be a great place to start, but where are you thinking?
You can flip the numerator and the denominator, and then you'll have a positive exponent.
Yeah, I like that idea of flipping it first, because sometimes when students distribute that -2 exponent through, I'm going to write it here, so they'll have like -12 raised to the -2 power. And so then they're kind of, unsure, do I, put parentheses around that -12? What am I doing exactly? So it causes a little bit of confusion there. So I agree. I think if the whole thing is raised to a negative exponent, I would just go ahead and flip everything, right? And if there were any negative exponents inside, we'd just keep those as negative exponents. Whatever's on the top goes to the bottom, and whatever's on the bottom goes to the top. All right, we're just flipping that, and then it's no longer a negative exponent, it's now a positive exponent. Okay? And so now let's just distribute that through. All right, and well, a couple of things here. Some people like to, reduce the fractions or reduce things first inside and then distribute, and that's a perfectly good way to do it too. So if that, makes it easier for you to simplify this first, you could do that. But it seems like most students think about distributing that next, right? So 3 to the 2nd power is going to be, whoops, I'm just going to write it as 9. I think you can see that. And then x squared. And then y to the 4th. Remember, a power raised to a power, you're multiplying those. All right, and then on the bottom, what do we do here about that -12? Anybody have an idea? Like, what? Is it the -12 that's being squared?
Yes, everything.
Yeah, so you don't have to worry about, that we're taking that -12 and squaring it. So this is going to end up being a positive, right? So -12 squared is going to be 144. And then x to the 6th power is again a power raised to a power. You're multiplying those. And then y squared, right? And let me give you a minute to just finish simplifying that up, getting everything together, and see what you come up with there. All right, I want to see what you guys came up with. So will you type it into the chat and then wait a second to hit enter so everybody has a chance to put it in there. So go ahead and enter in what you came up with for that answer. All right, 3, 2, 1, hit enter. Let's see what you guys have. All right. So it looks like a lot of you have, like, if we reduce the 9 over 144, right, that will give us 1/16 because 9 can divide into both of those. So we have a 16 on the bottom. With the x's, right, there's 4 more x's on the bottom than there are on the top, so we'll have x to the 4th down there. And then with the y's, there's 2 more y's on the top than on the bottom, and so we have a y squared. All right, so that's what you should come up with that. So if you didn't reduce it all the way, just be really careful with that. Make sure that you try and reduce it as much as possible, because on the test, we'll mark it wrong if it's not all the way reduced. So, all right, how are you feeling about those? Is that making sense? Thumbs up. All right. So someone in the chat did ask to go through number 35. So when we get to more similar problems to that, I'll go ahead and we'll work through that one then. So if I overlook it, make sure you remind me again, but we will definitely do that one. Okay? All right, what about the second one? How about, so when it says simplify, on something like this, and there's a denominator that has a square root in it or any kind of root in it, you're really wanting to rationalize the denominator. You don't want to leave anything with a root in the denominator. And that's what that meaning of simplifying, okay, is really all about. So with this one, what we're really thinking of here, let me write this down really quick. For some reason, my pen doesn't write very well on Word documents, so. All right, so what we're really looking for is what we need to multiply. Maybe I'll do this in a different color so it's really clear. Didn't start off with this stuff over here, all right? But what do we need to multiply this by so that everything comes out as a whole number, right? Since it's a square root, then our number needs to be a perfect square. So I'm thinking, well, 2 times 2 will give me 4, and 4 is a perfect square. So I'm just trying to make, match up that. So it's not necessarily that it would be that same number. It's whatever number I multiply together to get me a perfect square. All right, and then since it's a square root, right, I'm going to put this little 2 there, then everything's coming out, right, in groups of 2. So do we need to multiply by any x's?
No, just a y.
Okay, yeah, so since it's already, right, an even number, we're good on that. But the y, right, we need to make that an even number, so it divides in evenly, so we need to multiply by another y. And that will give us that y to the 12th power. Okay, and whatever we do to the bottom, we also need to do to the top. Okay, and then we're going to simplify there. And I'm just going to show you on this next one, just to make sure it's really clear why we're doing what we're doing here. All right, when I multiply these together on the bottom, right, I get 4, x to the 4th, y to the 12th. And then this is what I'm simplifying, and I'll do that on the next step. On the top, right, I'll have the square root of 14, x to the 14th, y to the 7th. Right, just multiplying those two together. Right. And then I can simplify from here. Let me come down here. Do this. So on the bottom, right, we know that everything on the bottom is going to come out as whole numbers because we made it do that. That whole reason why we multiply by that square root of 2y is so that would happen. So square root of 4 is 2, right? The square root of x to the 4th is going to be x squared. And the square root of y squared, or y to the 12th power, is going to be y to the 6th power. Right? Remember, you're just kind of dividing those Right, you're doing 12 divided by 2 gives you that 6. 4 divided by that 2 gives you the 2. All right, that's how that's working. All right, and then we need to simplify the top. All right, so if we look at 14, well, we'd want to do like a factor tree on that if it was a really big number to see if there were any numbers that could come out of the square root, but there is not, so that means I know I'm going to have some stuff that comes out, but then I'm going to have some stuff that's still stuck inside. So my 14 is stuck inside, all right, still. My x to the 14th, what will that come out as? Close. Not x to the 6th, but x to the 7th. Yeah, right? Because they're thinking, you know, again, that 2 there, how many times will 2 divide into 14? 7 times, right? And then similarly, what about the y to the 7th? So we're thinking, how many pairs, right, are there? So 2 divides into 7 3 times, so we have y to the 3rd power, but then there's still a y stuck in there that didn't have a pair, so it couldn't come out. Okay, and so, oh, whoops, sorry, we're not done yet. All right, what else do we need to do? Got over anxious there. What else can we do here?
Simplify the x's.
Yeah, so get the x's together, get the y's together, right? So if I'm looking at these x's, right, I see there's, you know, 7 on top, 2 on the bottom. So that means there's going to be 5 of them on top, right? If I look at my y's, there's 3 on the top, 6 on the bottom. So I know there's 3 more on the bottom. So that y to the 3rd is going to be down there. All right, and then this 2, can that 2 and that 14 cancel out? What do you guys think? No. Yeah, okay, because that's not really a 14, right? That's a square root of 14. All right, and if you did square root of 14 on your calculator, you get some crazy long decimal, 3.74165, blah, 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 right? So it's not really a 14, right? Square root of 14. So that 2 is going to stay on the bottom there, and the square root of 14y will stay on top. And now we're done. All right, and then we'll have our answer there. Okay. And please speak up if you have a question. Somebody else in the group has that same question. So please, please, please speak up. All right, if you're able to. All right, what do you think about this number 3? So I'd like to hear from you, either in the chat or say out loud. What do we do with something like this? So we're trying to multiply those together. But we notice that the roots are not the same. And you'll remember that when you talked about multiplying roots together, it said they have to be the same in order to multiply those together. Okay, so David's saying use rational exponents. So and I think that's a great place to start, right? So we could change this first one to be xy to the 2nd, all raised to the 1/4 power. Remember, the 4th root of something is really the 1/4 power. And the other one would be x to the 3rd, y, all raised to the 1/5 power. All right, and I like changing these to rational exponents because it makes it a little bit easier for me to be able to make sure I don't make mistakes with it, right? So remember, I cannot, I need to get a common denominator here in order to be able, in order to add those together because it's connected by multiplication. And so I want to be able to get those together. So let's think about this, right? So if I'm looking at 4 and 5, well, 20 would be our common denominator. So that means I'd want to multiply this one by 5 on top and bottom. And then the other one I'd want to multiply by 4 on top and bottom. Right? And so let me just write it out this way. So we really have 5 to the 20th power and then 4 to the 20th power. Okay, now what from here? A couple of different ways we can take it from here, but what are you guys thinking? What do we do from here? Anybody?
Distribute the 5 over 20 to the left and the 420 to that term on the right, and then combine the x's and y's?
Yeah, so you could distribute those through first, right? That would be a good place to start. You could change it back to like radical form if you think that would be easier for you to do. So there's a few different ways that you can do this. If we did, I think you guys understand how to do that distributing part, but if we did change this back to radical form now, right, our root is 20, and then we have this xy to the second all raised to the 5th power, right? Remember how changing that from that fractional exponent to the radical, right? That's where 5/20ths is. And then the other one would be, again, the 20th root, and that's what we were trying to do, make those roots the same so we could multiply these together. So that'd be x to the 3rd y, all raised to the 4th power, right? And then you could distribute the 5 through and the 4 through, right? So there's a lot of different ways that you can get there, you know, and so I don't want you to think that just because you may have done it a little bit differently that it's wrong, because there's a lot of great ways to do this, okay? So I'm just going to write it now all as one big root, because I know now that they're both to the 20th root. And so I'll have x to the 5th, right? So I'm distributing this through here. Make sure everybody's with me. And here. So x to the 5th, y to the 10th. And then on the other one, I want to distribute my 4 through to everybody. So that would give me x to the 12th, y to the 4th. And then I could combine the terms together that go together. All right, so I have x to the 17th, because I'm looking at my x's and I'm adding those exponents, right? And then I look at my y's, right? Y to the 10th, y to the 4th, so I'll add those together to give me y to the 14th. And if there was anything higher than, you know, to the 20th power inside there, then we'd want to take it out. But we don't have, you know, we have numbers that are less than that. So that would be our answer there. And just keep in mind, if it starts out in square root form, then your answer needs to be in square root form. Okay? If it started out as fractional exponents, then they expect your answer to end up in fractional exponents, even though you might be switching them back and forth through the process just to make it easier for you. Right? But that's kind of your little clue of how you know what form to write it in, because I get that question from a lot of students. How do we know which way to write it? And oftentimes in the instructions they'll tell you too. So look for the small print on what it's asking, how it's asking you to write your answer. Okay. All right. So much fun. You guys just having a blast. All right. So this next one, right, is telling us to rationalize the denominator. And so in something like this, all right, I want you to think about what do we need to do in order to rationalize this denominator. It's a little different than what we did up here, right, when we were rationalizing the denominator on number 2, right, because here we have a binomial on the bottom. Somebody tell us what you think there. What would we do there?
Multiply by the conjugate.
Yeah, okay. Melissa said that too in the chat. Awesome. All right, what would the conjugate be?
Square root 2 plus 3.
Yeah. All right, you're looking at the bottom. That's going to tell you what you need, and you're just basically changing. If it's a, subtract, you're changing it to add. If it was an add, we change it to subtract. All right, and then whatever we do to the bottom, we also have to do that same thing to the top. And then, really, you're just foiling these, right, from here. So foil the top, foil the bottom, and then simplify. Okay, so I want you to take it from here, and let me give you a couple minutes to try that out and see what you can do with that one. Looks like a couple of you are over here in the WebEx room. Let me put in the chat. We're actually at a different place. Did you see that message from me? Did you try and go into that? Let me share it with you and make sure.
I'm not seeing the chat.
I don't see anything in the chat either.
I'm putting it in right now, sorry.
Okay.
I put it in an announcement before, like when you were supposed to, when you went to the room, it should have shown that to you, darn it. I was hoping it would. Let's see. Sorry, because we did start on that other one. So try and click on that and then get into that room instead, because that's where we're working. I'll keep this window open just in case you have some problems. Just let me know. All right, well, I see Nathan. All right. See Nathan there now. Can you see my screen okay now, Nathan? Okay, and Athena made it in too. Awesome. All right, so this was the problem that we were working on, and we did a few before this, but so it looks like some of you are able to come up with an answer here. All right, so remember when we rationalize this denominator, multiply the top and bottom here by its conjugate, which in this case is square root of 2 plus 3, and then we're just going to be FOILing, right? So 5 times the square root of 2 is going to be the square root of 10, and then square root of 5 times 3 is 3 square roots of 5, and then we have 3 square roots of 2, and then 3 times 3 is 9. Right, and then on the bottom, square root of 4 plus 3 square root of 2 minus 3 square root of 2, and then minus 9. All right, and then we just need to simplify things up, which it looks like you guys did that nicely. We can get sometimes the things, together if possible. Sometimes we can't get it all together, but on the top, there's actually nothing we can simplify there, right? They have to have the same root and the same radicand. So the stuff inside that root needs to be the same to be able to add those together. So our top isn't going to simplify anymore. But on the bottom, we can see that the middle terms, right, are going to cancel out. And then square root of 4 is really 2. And so we'll have 2 minus 9, which gives us that negative 7. And so then that would be our answer for that. Is that what you guys came up with when you worked through it? Sorry. All right, looks like this did. That is great. Okay, so let's keep going then, working on some of these. Like I said, these are some different questions than what are on the review, but they will really be nice ones to know for the test. So I think you'll, see just going through a few more concepts that maybe weren't on the review can always be helpful with this. So let's look at this, solving these square roots, right? So when we're solving a problem that has some kind of a root in it, the first thing that we want to do is we always want to get that root isolated, right? We want to get it by itself. And so sometimes there's other stuff out to the side that we need to get rid of first, right? And just like if you had 3x plus 5 equals 7 or something like that, right? You'd subtract the 5 over and then divide by 3, right? None of that changes just because there's a square root in it, right? So we're still going to start with the subtract the 9 over, right? And then we have negative 4 square root of x plus 3 equals negative 7. All right, but the square root still is not by itself. Now we need to divide both sides by the negative 4. All right, and so that gives us square root of x plus 3 equals positive 7/4. Right? And then how do we undo that square root? What do we do now? How do you undo square rooting something? Yeah, square both sides, right? So you're always thinking in here, whenever there's a way to do something, there's a way to undo it. So to undo that square root, I square both sides. And it comes out of the square root. Move this up a little bit. More space here. So that all comes out, just leaving x plus 3 on the left-hand side. And then I need to square, oops, I thought I had a square there. And we have to square that other side, right? And so I really can just square the top number, square the bottom number. So that would be 49 over 16. Right, 7 squared is 49, 4 squared is 16. All right, and then to get x by itself, I just need to subtract my 3 over. Well, with this, it's kind of like saying 3 over 1, right? And so I need to get a common denominator because I have a denominator of 16 here, right? And so I'm thinking, okay, well, I need to multiply the bottom by 16, so it will be the same. So that means I need to multiply the top by 16 as well. Right? And that will give me 48. And now I can just subtract those now that I have common denominators. So x equals 1/16 would be my answer there. So that one was a little crazy because there was some fractions in it, but you guys can do it. You can work with the fractions, right, if they come about. Questions on that, though? Anything that I can help clarify there more? All right, I want you guys to try number 6 then on your own. So it's pretty similar, right? Solving a square root, kind of like what we did above. All right, so go ahead and try that number 6 and see what you can do there. I'm just going to give you a few minutes to think before we go through it. All right, let me see. You guys were able to get through that. Raise your hand if you came up with x equals 18 for your answer. And then did you check it? Do we need to check these questions? All right, so let's do a little check out to the side just to make sure. Sometimes people are like, I don't know if I have enough time to check your answers. Well, you could go through the whole test first, see what you come up with, and then go back and see if you can do some of those checks just to make sure. And on some of these, you really need to do the check because sometimes that answer will be an extraneous solution, and so it wouldn't work out. So it wouldn't be the answer, really. All right, but on this one, all right, we simplify inside the square root first. Whoops, where did my 4 go in front? All right, and so then I get really 4 times 4, because the square root of 16 is 4. So -1 plus 16 does give me 15. So that does check out. Yay! Right, so we know for sure this is a good solution. It's always a good idea to do those checks, even if it's just a little mental check if you didn't write it all out. But it's always a good thing to do there. Okay. All right. How about this one? So for number 7, right, we've got a 60-inch TV has a width of 52 inches. What is the height? Right, and then give exact answers in simplified radical form and approximate to 2 decimal places. So I'm asking for 2 different things, right? I want an exact answer and one that is approximated to 2 decimal places. But what are we going to use on that to be able to figure that out? B, if you can hear me, go ahead and click on that link and join us in this other room that's in the chat. Do you see that link in the chat? What do you guys think? What are we going to be using? How are we going to figure this out? All right, had somebody say Pythagorean Theorem. What do you guys think of that? Yeah, a squared plus b squared equals c squared. Right, that is a great place to start on that, okay? So go ahead and try and set this one up. How do you think you would set it up? All right, so that's 60, right? If we're talking about a television, remember that the way they measure televisions is the diagonal of the screen. So we know that this one has to be 60, and then it says it's 52 wide, and so we're trying to find that other one, right? And so we can, put 52 either in place of A or B. It doesn't matter which one we do, but I'm just going to put it in place of A, and we'll call B this other side. Oh, that looks really weird. All right, let me redo that. All right, so I'd have 52 squared plus B squared equals 60 squared. Go ahead and solve it from here. And again, I want you to try and write down the 2 different answers. I want it in exact form, which means simplified radical, and I also want it the approximation, right, rounded to 2 decimal places. Okay, so go ahead and do that. Let me try that out. All right, so look and see if you got to this point. Right? So to find b, we need to square root both sides. When we do that, we're just left with b on the left-hand side, but then we've got to simplify that square root of 896. Right? What did you guys come up with when you simplified, or you had this in square root form but simplified? You there? So what you might have to do, and I know this is kind of a big number to do this with, but you might have to just do like a little, prime factorization of this to figure out what that is. Some of your calculators actually will do it, right? But some of them don't, so you just kind of have to think, okay, well, what will divide into this, and then just kind of keep going from there, right? I mean, I could see that, I can just kind of keep trying some things. So 896 divided by 4 is 224. So I could do this, right? And then I just keep breaking this down. 4 will also divide into that one, right? And I can keep going and going there, right? So, hey Brandon, if you can hear me, go ahead and click on that link and come into this other room with us that we're going to be using today. Just click on that link in the chat. Do you see it in the chat? All right. So there's, a lot that you can kind of bring out here. So if you're looking to see, what that exact answer is going to be, you'll get 8 square root of 14, right? So what you guys came up with. Okay, so sometimes it'll ask you for the exact answer, but how does that help you? If you're going to buy a TV, right, and you're trying to figure it out, okay, well, will it fit in this space, for sure. That's not going to help you to know that, oh, well, it's 8 square root of 14 inches, right? Look at that and go, well, that was no help. So that's why doing the decimal approximation can also be, a better way on this. So it might ask for that. So what did you guys come up with that rounded to the nearest hundredth? Yeah. So make sure you're rounding to the place value where it's asking, right? To 2 place values, 2 decimal places. And on the test, right, look for that really closely. And the reason why I'm doing it here on the review is to try and help you, get into that habit of looking for that on the test, because I've noticed that some of my students, when I go back and kind of look for partial credit and stuff, I'm like, oh, darn it, they had it. They just went to the wrong, place value there. So yeah, so this one would be, 29.93. That's what that came out to be. Okay, inches. All right, questions on that one? How are you guys feeling so far? Is this making sense? Are you feeling all right? Okay, how about this? Find the midpoint between the 2 points. How do you find the midpoint? Somebody remind us. Well, midpoint is really just an average, right? So you're basically trying to find the average of the x's and the average of the y's. So your answer is still going to be an ordered pair, right? Because we're just trying to figure out where is the point that is smack dab in the middle of these two. So if I add my x's together, 2 minus 5, since it's a negative 5, and then divide that by 2, right? And then with my y's, 2 plus 3 is, oops, I'll do it this way, and then divided by 2, and then we can simplify here. So get negative 3 halves, and then 5 halves. Right? Or if you wrote it, I mean, you can look and see if it says in the instructions to write it as fractions or decimals. If it doesn't specify, then usually it will accept it either way. Okay? But sometimes they're trying to test on rounding it to a certain place value or see if you know how to use fractions with it. So that's why sometimes they say to write it in a specific way. But that would be your answer. That would be smack dab in the middle of these 2 points. Okay. All right, what about number 9 on here? What would we do here? Love to hear from some of you that haven't said anything. I know sometimes for some of you it's hard to speak, but so this is just a review that we're just doing here. It's not in the study guide. If you have questions off of the study guide, we can go through those, but I figured I'd give you some different ones to go through here. But they will be very helpful, I promise. Okay. Okay, any ideas? How would we do this? So it says divide, and I feel like sometimes those instructions on this gets people kind of like, I'm not sure really what to do. So can anybody help us out? What do you think we need to do here?
Multiply by the reciprocal.
I'm close. Not multiply by the reciprocal, but multiply by the conjugate. Is that what you meant?
Yeah.
Yeah, I thought so. So the conjugate of this, right, is going to be 2 plus 7i. And so then we just need to multiply by 2 plus 7i on the top. So kind of similar to how we did that other one. I just want to make sure you see the relationship on this, right? This number 4 said rationalize the denominator, but really all we did was multiplied by the conjugate. When we're dealing with i's like this, it gives the instructions divide, but really it's still meaning multiply by the conjugate to be able to get that answer. Okay, so just like we did before, we're going to FOIL on the top and we'll FOIL on the bottom. Okay, and then we got to remember things that we know about i's in the end there, right? That's going to change a little bit for us. So 3 times 2 is 6. And we got 21i, oopsie, minus 10i, and then minus 35i squared. And then we've got a FOIL on the bottom, but when we FOIL on the bottom, right, whenever we multiply a complex number by its conjugate, we always end up with a number, a whole number. We don't have the i's in there anymore, so that's why we want to multiply by the conjugate here. But let's see what happens. So we get 2 times 2 is 4, 2 times 7i is 14i, and we also get a minus 14i, and negative 7i times positive 7i is negative 49i squared. Right? And then we can see, oh yeah, look at those middle terms, right? Cancel each other out. So those go away on the bottom. And on the top, we can see that we can combine some things together here. And I also want to talk about this I squared, right? Remember that you've got to have memorized that whenever you see I squared, you're going to let that equal -1. So really here we have -35 times -1, which is really a +35, right? So on the top, we're adding 35, +35, and 6 together. So that will give us 41, and then we'll add those middle terms together too, or subtract them in this case, and give us 11i. Okay, and then what are we going to get on the bottom here when we simplify everything? I'll give you a minute to just try it and see. Okay. So remember, got that I squared again, so we've got to replace it with a -1, so that's really saying plus 49. Right, so we're adding 49 to that, and then the middle terms are just gone, so this is going to be over 53. But remember, it's not going to accept your answer in this form, because notice over here in the on the instructions it says write in the form a plus bi. All right, so how do we need to write this so that it's in the correct form? Can somebody tell us? What do we need to do there? Yeah, we're just going to...
Do you multiply by the conjugate again?
Not by the conjugate again. We just need to actually split this up into two different fractions. So really, it's just going to be, we're doing 41 divided by 53. Right, so that's going to be one of our answers. That's our A. Right? And then the BI part is going to be 11 over 53I. Do you remember that now? Just splitting those kind of up in there. So just...
So if there's an I on the bottom, it's not simplified?
Yeah, if there's an I on the bottom, it's not simplified. And that's why we're multiplying by the conjugate on this one, so that we don't have any I's. The I's actually will cancel out and they'll go away. All right? If you do end up with an I on the bottom and you thought you multiplied by the conjugate, then you probably did something wrong when you FOILed it.
Okay. Do you mind doing one more?
Yeah, we can do another one.
Okay, cool.
Yeah. So let's do another one here. I'll just call this 9b. All right, so it would be kind of similar to this, and we'll have everybody try this one. So let's do this one. I'll just do 4i over 3 plus 5i. Okay, so go ahead and see if you can think, what would you do first here? Okay, so hopefully you started off by multiplying by the conjugate. Can somebody tell me what is the conjugate that we want to multiply, or top and bottom by? Yeah, 3 minus 5i. All right, so if we do that to the bottom, that's going to get rid of our i's, which is what we're trying to do. And then on this one, right, we don't have to FOIL on the top, we're just distributing that 4i through to both of them. But we are still FOILing on the bottom. Okay, but go ahead and let me give you a couple more minutes to try this out. Simplify that all up and make sure you get it in that form of a plus bi. Okay.
have this question.
Yeah.
So on the bottom, I noticed you like put the -1 where the I is, so you can get rid of that I. How come you don't do that to the top and get rid of the I completely?
You can't get rid of the I completely because all we know is that I squared is -1, right? I isn't -1, just I squared. So on the top here, I can change that I squared, right? Replace that with a -1. And I do the same thing down here. That's also a -1 there, right? But the -25 times the -1 is going to give me this +25. And so really, all I'm adding together, all I have left to add together is that 9 and 25. But these guys are just opposites of each other, and that's why they cancel each other out.
Okay, that helps me a lot. I wasn't thinking about the I squared thing. Thank you.
Yeah, you're welcome. All right, so then on this, if we take this further here, right, because this isn't written in the right form yet, but if we go like this, right, split it up so that we have 34 on the bottom of both of those, well, this one can actually simplify further. And if you don't simplify, like our one up here wouldn't simplify. 41 and 53 don't have any common factors. 11 and 53 don't have any common factors. So we can't reduce those fractions. But on this one we can. What number do you see that will divide into both 20 and 34? Yeah, 2 will, right? 2 goes into 20 10 times and into 34 17 times, right? And same thing here, 2 divides into 12 6 times and into 34 17 times. So you just want to make sure that you reduce those fractions if they can be reduced, because it will mark you wrong if you don't. Right? And you could write it as 6i on the top over 17 or 6/17 I. It'll accept that either way. But it does need to be reduced. Okay? Did you guys remember to reduce it? Or did you get it here and we're like, oh good, I got it. So
I reduced it, but I couldn't remember if that was okay, because I know like with some of these you can't. So the 6, well, I mean the 12i, if that was a different number, would we still be able to reduce it? Like if
what do you mean? Like if it was...
So like if 10/7, like 20 over 34 could be reduced, but that 12i was a different number, could you still reduce the 20 over 34?
Yeah, you can. So if it was said like, you know, 13i instead, right? Then that fraction wouldn't be able to be reduced. So you just leave it as 13 over 34i. But then you would reduce the other one. So yeah, good question. And that's why it's easier to, you know, make sure that you split these up into 2 different fractions, because then it's really just, okay, I'm reducing, you know, this fraction, and I'm also reducing this fraction. Right? So it makes it easier. Good question. I like that question. All right, you definitely can. All right, so hopefully that was helpful there. All right, going through some of those, because I think it's just sometimes tricky, the wording of it. Divide, you look at that and you're like, wait a minute, what am I doing here? Am I doing long division? What am I doing, right? So I just want you to, you know, put in your notes somewhere when it gives you the directions to divide and you have imaginary numbers, what you're really doing is multiplying by the conjugate. And so that seems kind of weird that that's the instructions, but it is. Okay. All right, what about this next one? So we're given 2 roots, right, of a quadratic equation, and we're asked to write the equation. So it's kind of like we're given something a little bit backwards, right? We're used to having the equation given to you, and then from there you find the roots, right? You figure out what x is. But this time they're telling you that x is 1/2 and x is 2/5. So how can we use that idea, or this this information, I should say, to write an equation. What do I do with that?
Reverse the steps.
Yeah, right? We're going to reverse the steps. So we're going to get everything over to one side. So that means, all right, I need to subtract my 1/2 over to the other side. So that will give me x minus 1/2, right, equals 0. And then on the other one, right, if I subtract that over, then I would get that x minus 2/5 equals 0. Okay? And I mean, and sometimes people are like, oh, I don't like dealing with these fractions and stuff. I mean, you could clear the fraction if you wanted to, so you didn't have to deal with it. Like on this first one, you could multiply that whole thing, that whole equation by 2 to clear that fraction, right? Or if you're like, I can do it with the fractions, then remember you would just set those right by each other, because these are the factors, right? And then I could just FOIL those together, and that will give me the answer. But in the end, you're going to have to, like in the next step, you'll have to kind of change it to, so there's no denominator as well. So if you find that it's easier just to clear the denominators first, so let me show you that way first. So if I multiplied this equation by 2, right, then I'd get 2x minus 1. And that would be my first factor. And on the other one, right, in order to clear that fraction, I'd multiply it by 5. And so I would get 5x minus 2. And then that looks a lot easier to FOIL together for most people. It doesn't cause a lot of anxiety. Sometimes seeing just those fractions there and going, oh no, I have to work with these fractions. So you don't have to. You can clear the denominator and, multiply that all through, right? You're just really distributing that through so you can get rid of that fraction. Does that make sense? Or have I lost you guys? I can't tell.
Yeah, that makes sense. I've seen it before, so I'm glad you brought it up again.
Yeah, you bet. Okay, and so then let's just FOIL that together. So 2x times 5x is 10x squared. 2x times negative 2 is negative 4x. Then I've got negative 5x, and then a positive 2. And then, like I said, you're going to get our like terms together, and if you decided to do this, multiply these together with the fractions, you're going to get fractions in your equation, and then you're going to have to multiply by the common denominator anyway at that point. So I think it's just easier to do it first, personally, and then you're not so worried about, am I multiplying this together right? Do I have to get a common denominator? Right? You don't have to worry about any of that stuff. So we get 10x squared minus 9x plus 2 equals 0. And that would be the equation that have these two roots, right? X equals 1/2 and x equals 2/5. Okay, so it's like undoing our steps. So it's kind of like on these whole chapters, it seems like there's a lot of learning it one way and then learning how to undo it, right? I mean, there's just a lot of that here, but that's what a lot of math is just kind of understanding that when there's a way to do something, there's always a way to undo it. And sometimes that undoing it is going to be an easier way for us to go about it. Okay. All right, so let's look at the one, number 35. Somebody at the beginning asked to look at the number 35 off of the review. And I would love it if some of you have more questions off of the review, the study guide that was given. So I'm just going to put study guide number 35. Right, that's what this one is from. And it says, again, it says write a quadratic equations whose solutions are 5i and negative 5i. Right, so we're doing kind of the same thing that we did above, right? Trying to write a quadratic equation, right, with solutions of 5i and negative 5i. Okay? And if it helps you, again, to just write it down like the other ones are written, like we're saying x equals 5i. Right? And this one says x equals negative 5i. That's what our x's equal. Those are our solutions. But sometimes they just give it to us this way and they don't like tell us, you know, specifically that it's x equals that. But again, it makes it a little bit easier for us because then we're like, okay, I got to get everything back over on the other side so that it's equal to 0. And that's what I did on the other one. So I want to subtract that 5i over, which is going to leave me at x minus 5i. All right, so that's going to be one of my factors. And here, right, if I add the 5i over, then my other factor is going to be x plus 5i. And then I just need to FOIL those together to get my answer. It's going to always equal 0 because this is an equation here. All right, so x times x is x squared. X times 5i is 5xi. And then I get negative 5xi. And then negative 5i times positive 5i is negative 25i squared equals 0. Okay. And then what would we get there? Go ahead and I want you to type it into the chat when you have your answer. What would that equation be? Let me simplify this up. Remember that we're trying to write an equation, so we're not solving something. We want to keep it in equation form. All right, so we can see our middle terms cancel each other out, so we'll just get rid of those. We know that I squared is negative 1, so I'm doing negative 25 times negative 1 is going to give me a positive 25. So my equation should be x squared plus 25 equals 0. So you guys got? Okay, and it needs to be this plus because think about it, we have these imaginary solutions. And remember how we said this x plus 25, that can't be factored any further. If it asks you to factor that, right, this is something totally different, right? But if it asked you to factor this, well, you can't factor it. There's no way. Because what times what is 25 that adds to be 0? Well, you can't say, you know, 5 and 5 because that's going to give you a middle term. We can't say negative 5 and negative 5 because that will give you a middle term. And you can't have a negative 5 and a positive 5 because it needs to be the same number. So this does not factor at all in the real, real number system, right? But when we tried to solve that, right, so let me show you here. If you tried to solve it, we could use the square root property here, and then we're like, oh, right? So this is how we're getting to these imaginary solutions that they're giving us to start off with. And I think sometimes it's just like, it's so easy to just, get caught up in, did I do what they asked me to do or not? So this is the answer. right? Let's make sure it's really clear. This is the answer. It asks you to write an equation, right, that have these two solutions. And I was just showing you the way that we usually do it, right? We start off with the equation, we solve it, and we come up with these solutions. Well, we had to work it backwards to figure out what that equation was, and that's what we did here. Okay, does that make sense? Yeah, there are some different answers on that, and I can totally see, you know, what you were thinking of, you know, on that. So, okay, so hopefully that helped clarify a little bit more, because this is definitely a type of question that you could see on the exam, you know, just working with these imaginary numbers. Okay, okay, awesome. All right, let's try, we've got a little story problem here, and we've got a few different things that we're trying to figure out. Okay, so on this one, it says a flare is launched upward at a speed of 80 feet per second. And let's see, get this a little bit smaller so we can put it all on there. Oopsie. Right, and from a height of 224 feet is modeled by the function that, right? So you don't really need this information. They're going to give it to you. You've seen it on story problems, but they're using that information to make this quadratic equation and this function that they have there. So you don't have to know how to write these functions for the test, okay? It will be given to you for sure. And then you're going to use that, right? And you've got to make sure you notice it's saying h of t is the height, and then t is the time in seconds. Okay, let me make this bigger again so it's easier. Whoa. Right? Because really what we want to focus on there is that function that was given to us. Okay? And then look at the different parts here. Right? So we want to A, find the time that the maximum height occurs. B, find the maximum height, right? And then at what time or times will the height of the flare be 300 feet? Right? And then part D, when will the flare hit the ground? Okay, so those are the things that we want to kind of talk about here. So let's focus on A and B first. When it's asking you to find a max or min, right, a maximum or a minimum, what is it really asking you to find?
The vertex?
Yeah, the vertex. Right? So we got to make sure that we understand that it's really wanting us to find the vertex. And the vertex on this, I like to write down what the x and the h of, or well, I guess in this thing it's the t and the h of t, right? What they represent. So I don't get mixed up on my answer, which one I need to put where, right? So remember, t is the time in seconds, and then h is the height in feet. So I sometimes just write this down to help remind me, right, what the first coordinate represents, what that second coordinate in the vertex represents, right? And then remember, I can find that first coordinate by doing negative b over 2a. Right, so this is a little formula that you need to know, this vertex formula. So if we do negative 80 divided by negative 16 times 2, right, 2 times that negative 16 is negative 32. All right, and let's go ahead and simplify that. What's negative 80 divided by 32? So I would say not to leave it as a fraction unless it asks you to leave it as a fraction, right? So I would just put it as like 2.5 seconds, right? Because remember my time, or my first coordinate is going to be seconds. Okay, and then let's go and find that h of t. And to do that, I just need to plug 2.5 in everywhere I see a t in my formula. So negative 16 times 2.5 squared plus 80 times 2.5 plus 224. And I know some of you can just, your calculator will let you put all of that in. Right? So I'll give you a minute. And if not, make sure you're using the order of operations so you do this correctly. And go ahead and type in the chat box when you have an answer on that one. What is that height? Okay, awesome. So coming up with the same thing, 324 feet, right? Okay, so now let's look over here, right, and make sure that we put the things in the right place, right? So what time, find the time? Well, it happens at 2.5 seconds, right? And it's 324 feet high. So part A should be at 2.5 seconds, and then 324 feet. Okay, so that's just still. Okay, did you just forget a negative somewhere, I wonder, B? Because that's a really good thing to bring up, though, because if you tried to simplify negative 80 over positive 32, you'd end up with a negative 2.5 seconds. And hopefully from that, you're going to be going, what? How can it be going negative time? That doesn't work. So that, hopefully we'll have you look for those signs and stuff again, going, did I miss a sign somewhere that I needed? Right? But that's always a good thing to look at. Okay, all right, what about part C? So at what time or times will the height of the flare be 300 feet? So what are we going to do with this? And then round to the nearest hundredth, also says. Okay, well, it's telling us the height is 300 feet. So where are we going to put 300? Yeah, put the equation equal to 300. So in place of our h of t, right, is where we need to put 300. So just like Austin was saying, we'll do 300 equals negative 16t squared plus 80t plus 224. All right, and then let's get everything over to one side. So we'd want to subtract that 300 over so that we have it equal to 0. All right, and then 224 minus 300 is negative 76. All right, and then from here you could try and factor it, but this doesn't look very promising to me to factor. And so then in that case, you need to either do quadratic formula or complete the square. And we haven't talked about what to do with complete the square when there's a coefficient out in front that's not a 1. So that limits our options to we've got to use the quadratic formula, right? So remember, the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so gotta know this quadratic formula. It's going to come in handy a lot. And then make sure you see what your a, b, and c are, right? You can't pick out what your a, b, and c are unless everything's over on one side. Now that it is, you know that a is negative 16, b is 80, and c is negative 76. So these are some pretty big numbers, but you got your calculator, right? So you can, you know, use that and help us simplify with it. So I want you to take a couple of minutes, right? Plug those numbers into the quadratic formula, right? And then remember, the direction said round your answer or answers to the nearest hundredth. Okay, I'll give you a few minutes on that. Oh, good. Yeah, pop goes the weasel tune. Yep. I know. I did it in my live class, so it's just a good one. So you don't have to keep looking back at it. All right, let's look at this and see. Just kind of make sure, you know, double check. If you didn't come up with, you know, what I had here, then maybe put the number in the wrong place or something like that, right? But these were some pretty big numbers there. But when we get everything simplified inside the square root, it simplifies to be that 1536. Right, and so remember, there's two different answers we're going to come up with. The negative 80 plus the square root of 1536 divided by negative 32, and then negative 80 minus the square root of 1536 divided by negative 32. And if you came out with negative answers on either of those, then you would disclude them, right? Because you can't have a negative amount of time, which is what we're looking for, right? What time will the height be 300 feet, right? But if they're both positive, then we would use both answers. So what did you guys come up with for your answers, rounded to the nearest hundredth? Yeah, Athena came up with 3.7, I think that's this one, 3.72, and this one is 1.28. Right, and they both came out to be positive answers, so they're both good answers. So, you know, just a little over 1 second, it's going to be up at 300 feet, and then when it drops back down, right, so think about how this is going, right, it's launched from the ground, it goes up, you know, maybe 300 feet is right here, all right, so it's going to hit that 300 feet on the way up and on the way back down, right, so that's why we get these two different answers on it. All right. Questions on that? Even if it's just something with that simplifying, were you okay with simplifying? Those numbers were huge. Okay, what about part D? When will the flare hit the ground? What do we need to do on something like that? How do we figure out when it's going to hit the ground? All right, so here's the ground. All right, it started at the ground. It's going to go up, right, and over, and then eventually come back down. And we want to know what time it hits the ground. What do we need to do there to find that? What are we trying to figure out? On the last one, we were trying to figure out, okay, what time will the height be when the flare is 300 feet? Well, this one, we're still trying to figure out what time, right, will the height be at 0 feet? Right, because the ground level is at 0 feet. So instead of like on this one where we put the 300 in place of our h of t, we're going to put 0 there. Okay. This one actually works out nicer than part A did, right? So I have 0 equals negative 16t squared plus 80t plus 224. And you could use the quadratic formula on this again to figure it out. But oftentimes on the tests and stuff, they make it so that you can factor it, and it would be a lot faster to do that. Because look at what happens here. We can factor out that negative 16 out of all 3 of those terms. Right? So if I divide each of these terms, right, it's basically what I'm doing. I'm dividing each of these by negative 16, and they still end up becoming whole numbers here. And so that makes it really easy for us to factor it. So we'll have t squared, then 80 divided by negative 16 is negative 5t, and then 224 divided by negative 16 is negative 14. Okay. And then look at how we can just look at how easy this one is to factor, really. Right? So this one factors to be t times t is our t squared. What times what is negative 14 adds to be negative 5. Well, I know 7 and 2. 7 must be negative. 2 must be positive in order for us to end up with a negative 5t in the middle. All right, and then I can just set each part equal to 0 and solve it. Well, I don't need to do the negative 16 part because there's no t there to solve for. So I'm just going to do the t minus 7 equals 0 and t plus 2 equals 0. And so if I solve these, I get t equals 7 and t equals negative 2. So are both of those good answers? Why or why not?
Two would not be a good answer because it is negative. Negative 2 would not be a good answer.
Yeah.
And because we're working with time, and time can't be negative unless you're a time traveler.
Perfect. I know some of us, I'm sure we wish we could, but as far as I know, we can't. So yeah, so when we were talking about, and even putting your labels on it when you're working through it, will kind of help you see, oh, wait a minute, this can't be, right? I can't have negative 2 seconds. So that means that your answer must be 7 seconds. So from the time that flare takes off to when it hits the ground is going to take 7 seconds. Okay. All right. So kind of, I mean, and if you're kind of thinking about, you know, the graph of what's going on with it too, that sometimes can be a little bit helpful as well on there. Okay. We only have a few more here to do, but I just want to make sure, you know, that we get to ones that you want to make sure that you know, if you had questions on the review that you want to look at. I didn't see anything show up in the chat besides the number 35, but I could have missed something in the chat. Did anybody want to work through anything else on that study guide for the test? Okay, well, let's look at this one then, because on something like this, right, it gives you all these different things that it wants you to find, and then you're going to use that information to graph it. And that's basically what we're trying to do here, is graph this. But it's going to ask you quite, you know, different steps along the way to do that. Right? So on the first one, I probably won't work through the first one just because I think most people remember what to do there. Right? But you're just taking that negative 2 and you're putting it in place of x. I mean, well, maybe I should work through it just because sometimes people get a little bit confused when that's a negative. So we're figuring out, so if I have negative, right, and then next to that, negative 2 is going in place of x squared plus 6 times negative 2 plus 5. So you got to be careful on this because a lot of times people just put in, they say, oh, that negative times the negative is a positive, and then I square it, but that's going the wrong order of operations, right? I have to take that negative 2 and square it first, which gives me 4, and then really this is kind of like, I'm gonna write this down a little bit differently, this is kind of like a negative 1 that's out there, and you have to remember that you're multiplying that by a negative 1 after, right? So that's really negative 4, and then minus 12, and then plus 5. So negative 16 plus 5, so negative 11. Right? So, and that's a point on, so we know that when x is negative 2, y is negative 11. So there is a point on the graph that could help us, right? So that is part A. Right? Part B says to find the vertex, and we already did that kind of in the last one, right? But it was a little bit, you know, different. This one's telling you to find the vertex, where before it was just saying you had to find, you know that when it's saying find a maximum or a minimum that you're finding the vertex. Okay, but let me give you a minute. Go ahead and try and find the vertex of that one. Okay, so Kelsey's saying she can't find the study guide. If you go into the module that says Exam 3, okay, and there's like preparing for Exam 3, you'll see that it's on the same one where they have all the videos and stuff. If you want to stay on just a few minutes after, I can show you where to find that. All right, double check me on that. Is that what you guys got for the vertex? Do that right. Okay, and then part C, I don't know if you guys noticed, but on some of your homework questions and stuff, sometimes it said find the vertical intercept, and that really meant the y-intercept, but I want to just make sure that that's clear, that, you know, if it says that word vertical intercept, it's meaning the y-intercept, right? And the y-intercept is always easy to find, because remember, to find the y-intercept, you let x equal 0 and then solve for y. So we have y equals, here's our little function, right? And we're just putting 0 in place of x. So 0 squared times negative 1 is still 0. 6 times 0 is 0. So really, that is always going to be that last, you know, whatever that constant term is going to be your y-intercept. But if it asks you to write it as an ordered pair, right, you got to remember x is 0, so we'll have 0, comma, 5. And that would be your y-intercept. Okay, so that one's usually pretty easy to find when it's written in standard form, right? Let's see, nobody said anything about B. Are we good with B? Is that what you guys came up with? Do you remember about this negative out here? Sometimes, again, sometimes people put positive 9 instead of negative 9. Because they forget you have to square the 3 first and then times it by the negative 1. Right? Just tricky little things like with those negatives that I want to make sure that you look at so you don't make those kind of mistakes on the on the exam or the final. The final is getting close. Please believe how close we are to being done here. All right, part D. So again, sometimes the wording of it is weird, but what if it said find the value or values of x when f of x equals 0? Well, really, this is saying, y equals 0, right? So it's like, saying, so what is x, right? So find x when y equals 0 is really what that's saying. And then it's telling us to round to the nearest hundredth on this, right? So you're really finding the x-intercepts on this one. But sometimes they don't come right out and say that. So I want to make sure if you see it in that way, you understand what it's saying. So we're putting 0 equals negative x squared plus 6x plus 5. And then we could see if it factors. It looks like it might factor, but I want to factor out a negative 1 first, since I've got a negative 1 in my leading coefficient. So negative 1 factored out leaves me x squared minus 6x minus 5. And then we'd want to look and see if this could factor. All right, so what times what is negative 5 that adds to be negative 6? What do you guys think? Does 5 and 1 work? Let's look at it. All right, so if we have 5 and 1, in order for it to be a negative 5, that means one of them would need to be negative. All right, but then it needs to add to be a negative 6. The only way to add to be a negative 6 is if they're both negative. All right, so it doesn't look like this one's going to factor. It's just off by just a little bit there, right? You see that? So on this one, you'd have to use like the quadratic formula or something on that to get that answer if it doesn't factor, right? And Natasha, you said negative 6 and 1. But remember that we're looking for what multiplies to be 5, not what multiplies to be 6, right? I was actually doing that same thing in my head before I started writing it down, and I was thinking of these two backwards. I was thinking of the 5 in the middle and the 6 on the end, but that's not the way it's written. So, all right, so this doesn't factor, so let me just get rid of this, all right? And then we can just go back up and we can use this, negative, do our quadratic formula where a is negative 1, b is 6, and c is 5. Okay, but I'm not going to spend more time doing that. I think you guys are good with the quadratic formula and knowing how to get that done, right, with using the quadratic formula. So let's talk a little bit about what's the line of symmetry and how can I find that? All right, well, the line of symmetry, remember every parabola, doesn't matter what parabola we're talking about, they always are symmetrical, right? And they always have a vertical line in which if you folded it over on that vertical line, right, so the fold was on that dotted line, that the parabola would land on top of itself, right? One side would land on top of the other side. And so that's what we're talking about, is that line of symmetry. And that line of symmetry can be found by knowing the vertex. So if you already found the vertex, right, we're just thinking of, well, what was the x-coordinate for the vertex? Because that's where it has to be. Because think about it's saying, go over 3 and up, well, this isn't the right picture for it, and up 11, right? And so that means that our line of symmetry is just going to be the line x equals 3. right? And that's a vertical line. Let me get rid of this picture because this is not what this is going to look like at all, and I don't want that to confuse some people. I was just trying to explain what the line of symmetry was, how you find it, right? And so remember, you can find it by looking at the x-coordinate of the vertex. That'll always give you that line of symmetry. All right, but let's do part F, because this is the part that we got to make sure that we know how to do, right? The whole graphing of it. So we do know that it's an upside down parabola because that -1 in front of our first term. So we do know that it should be an upside down parabola, right? And we found our vertex to be 314. So I'm going to plot that one first. And it's important on your, like when you're graphing parabolas in Lumen, you know, like on the homework program, you always have to start with the vertex and then give one other point on the parabola. If you try and give the other point and then the vertex, it doesn't know what you want to do. So always start with the vertex. So over 3, wait a minute, I forgot again what it was, 314. So we're going to go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 14. Okay, so here is my vertex. And then I can see that I have some other points that I could use, right? I know my y-intercept is 0, 5. So 1, 2, 3, 4, 5. It's like about right there. And I know it's symmetric, so I could think about where that would be on the other side, right? I know that my line of symmetry is going through here. Right, it's to go through that vertex. And so if I can see how I have 3, you know, 3 places on this side, then I know I have to go over 3 places on this side, and I could put another point there. All right. So if you were drawing it out, you know, but really with your, you know, with what you can do on your homework or on the test, you only need that vertex and then one other point. And then you could just kind of draw your parabola from that. Okay. Oh, that parabola looks like a V-shaped graph. That should be rounded there at the bottom. Right? So an upside down parabola. Okay. All right, hopefully you're remembering this stuff, and if not, I hope it's a good review and it's coming back to you, right, on how to do this. So on number 13, again, it's talking about minimum cost. So remember when it's asking you for maximum or minimum, that you are finding the vertex. Okay, we're kind of running out of time here. We only have 4 minutes left, so I might skip that number 13 because it's kind of similar to one we did before. And even though you have, you know, crazy numbers, decimal numbers here, it's okay, right? I mean, to find that, you know, the vertex, you're just doing -b over 2a, and then you're just plugging whatever you get for x into this function. So, okay, so that shouldn't be too bad, but sometimes you'll see these crazy decimals and stuff. All right, let's look at this last one. So number 14, right, this is solving these quadratic inequalities, right? So we've got a less than or equal to sign. Sometimes it might be a greater than or equal to sign, right? But on this one, you want to make sure you get everything over to one side, and I would encourage you to move everything to the left side because it's going to make reading your inequality a lot easier. So meaning I would add 5x over and I would subtract 6 over, right? And so then that's going to give me x squared plus 5x minus 6 is less than or equal to 0. right? So really what this is saying on here, right, when I'm trying to find where is it less than or equal to 0, well, I really want to know, where is the graph below the x-axis? Right? And so to do this, right, the easiest way would be to try and factor this. Let's get this in factored form here. This was the one, right? So what multiplies to be -6 that adds to be 5? So let's see, is that going to be 6 and 1? We've got a +6 and a -1. Right? And then I'm going to set each of these parts equal to 0, right? Because I want to know where is it crossing the x-axis, because that's going to kind of clue us in to the inequality to help us figure out where it's less than 0. So x equals -6 and x equals +1. Okay, so let me draw a little picture over here of what's going on. So I know that it's crossing the x-axis at 1 and -6. All right, so those are the points in which it's crossing the x-axis. And I know, since it's a +1, right, it doesn't have a negative in front of it, there's an invisible +1 here, I know that this is a right side up parabola. And I don't know exactly how far that goes down, but that doesn't matter for what I'm trying to find here, right? I know that it's going to go below the x-axis between -6 and 1, right? So this is the part of the graph that's below the x-axis. So my answers would be, all of the x's in between -6 and 1. So my answer on this, since it has the equal to part, right, we are going to use square brackets. If it didn't have the equal to and it just said like less than or greater than, then you'd have to use parentheses. Right? But we do have this, so we're going to go from -6, right, to +1 is the part of the graph that's going to go below the x-axis, and stuff that's less than 0. Okay? And that would be your answer. Okay? All right, I hope you guys found this helpful, and I wish you all the luck getting ready for this test and everything. And please, reach out to me if there's anything else I can do to help you get ready for this. And I'm going to record this. I did record it, so those of you that are in my class, it'll just be under the Exam 3 module. And those of you that aren't in my class, if you would like a copy of it to go back over anything, you could just ask your teacher, and I can send it her way or his way. Okay? Yeah, I can send it to Melissa. Okay, because I know some of you. So I'm not doing another review. I didn't check the site to see if anybody had posted any other reviews, so I'm not really sure if any other instructors did. But remember that, let's see, I'll show you right now, those of you that are curious, because I know Kelsey wanted to know. Your class might look a little bit different than mine, but it will be really similar. So let me pull this over here so you can see this screen now. So let me just go into one of my courses here. And so yours should look pretty similar to this, and you'll see that there's, you can click on Exam 3, and then in my classes it might look a little bit different, but everybody should have something that says Summer Exam 3 Information, and then that review session is just a discussion. But if you click on this Summer Exam 3 Information, right, there's a link here to go look and see when there is workshops and stuff. And then here are the study guides. And then they show the keys for them too. And there's also the videos of another instructor working them out too, so you can see those worked through. So that's just on that part that says Summer Exam 3 Information. And all of you should have something in your modules that look like that. Okay. All right. If there's any other questions, if you want to stay on and ask me some individual things, I'm more than happy to stay on for a few more minutes to help you out. Otherwise, I will let you guys go and have a great night. And good luck on the test.